All right, so in part one, we were talking about converting rectangular equations to polar, and so now we're going to do the other. We're going to convert from polar to rectangular. So our goal is to get some sort of x equals or y equals, or both, and that's our goal. So we're given some polar equations, and we're not going to do that. We didn't do that in our session today. We're not going to do that, so cross that out. We're going to take what we know about conversion from our notes up here again. Any of this stuff we're going to try to substitute so it's as easy as possible, just like we did in video part one. So for our first example, we have r equals 5 secant theta. If you remember, secant is also the cofunction to cosine and vice versa. So, and we have this x equals r equals cosine theta substitution that we can do. So if we try to change the secant to, cosine, which we can do, if you recall, secant is 1 over cosine theta. It's the reciprocal function. We can try to get this into a rectangular form. Okay, so you can write it as 5 times 1 over cosine theta, or r equals 5 over cosine theta. I don't care how you write it as long as you have something like that. So our goal is to get something where we can have an x, y, or both. Okay, so we need to get rid of the fraction or the division. So we're going to multiply over by cosine theta. Okay, so if you multiply over, you're getting rid of the division that you have here with the fraction. Okay, and so now you should have r cosine theta together, and that equals 5, regardless of how you set it up. And at this point, r cosine theta is equal to x. Right? That's what we have up here. So we can say x equals 5. So what this means is we just took a polar equation and we created basically an equation on our coordinate plane that's a vertical line. That's what we did. Okay. Some of them are harder than others, so this is on the less challenging side. So I want to practice one more, and then we'll go into a little bit more challenging. So this next example, r cosine theta equals 6. Just like we practiced, x equals r cosine theta. So that means that this right here, this highlighted blue, r cosine theta, is also x. So now we have x equals 6. Okay, so that's on the easier of the substitution. The next one we're going to take a look at is this example right here, r equals 2 sine theta. Okay, we're going to use a combination of y equals r sine theta and our x squared plus y squared equals r squared. We're going to use a combination of those two. So first thing we're going to do, because if we divide like we just did, so our strategy is to be as simple as possible for this. If we divide over or get rid of it, we still have division on this left side. So I know the strategy is going to be trying to move this sign, but that's not what we need to do because we still have division here and we don't want division. That's not what we're looking for. We're trying to get this to be x, y, or both, and that's not how we're going to get that done because the r needs to go away. And we can't get the r to go away like that. So what we're going to do is we're actually going to multiply both sides by r. So that gives us an r squared. And that's going to equal 2 times r sine theta. Okay? So if we see something like this, we can multiply by r. So now we have an r squared, and we have an r squared here. R squared is equal to x squared plus y squared. Well, I can take my r squared here, and I can substitute in my x squared plus y squared. Okay, so that's done on the left side. So we have x's and y's. On the right side, this part right here, the r sine theta, that's y. So I can say is equal to 2y. So now we want all of our x's and y's together. So I'm just going to do something very simple and move my 2y over. So I have x squared plus y squared minus 2y, and that's just going to equal 0. So for right now, we are leaving this as our answer. There's more you can do with it to make it simple. You know, we could factor and do a whole bunch of stuff with it. But all I care about is that you know this process, this substitution from polar to rectangular and vice versa process, okay? So if you can get to this point, we're good.